This computer. There you go. Ivett, take it. It's all yours.
I told you a million times that this isn't clean code. This is crap, and I hate it. You're absolutely right. I have violated every rule you have. Let me refactor that for you. Why couldn't you do that the first time? Really? Why? That's what we are going to talk about today. Because here's the thing. I've been, I learned coding when I was 8 years old. And one of the things that I learned very early on is that if you want to make progress, you got to make sure that the code you write is maintainable. And when I heard people talk about how we are going to have these machines write thousands of lines of code in seconds, I knew what's coming, and it wasn't good. But at the same time, like I am a solo business. I do everything myself. And I have so many ideas. Like I have ADHD. Of course I have so many ideas. And like I wanted to make them real, but if I have this wonderful tool that can write me code, and it could write me code like this, it would be so amazing if I could just let it do things for me and write code like this instead. And this is actually code that Claude wrote for me. Hasn't been refactored by me. Like, it's not perfect. Probably I could find a problem with that, but like, it's so much better than the default. And here's the thing. It's not just about aesthetics. Because one of the things that we should care about is how much effort we are spending on this. And what I see is that people can build these little toys in hours, right? These very slides are vibe coded. Like this is not a presentation software. This is HTML you're seeing. And I vibe coded it in an afternoon. But when people start to do like serious stuff, then they run into a pretty bad issue, especially these days that companies are starting to charge fair price for the tokens. And if your code is not maintainable, what I want to convince you about today, if your code is not maintainable, then this is going to be expensive. It's going to be harder and harder to make progress, and it's going to be more and more expensive. So we should care about code quality. Now here's the thing. Well, why should we care about code quality? And this is the part where I think there is one thing that most people don't get about large language models. And this is the thing that I want you to show you first. Because almost everyone knows by now that an AI agent or an LLM is going to take some tokens, like read some text, and then predict one word at a time, right? We know that. Okay. But I have a question for you. When that token is being predicted, which part of this context influences that word? Is it the entire text? Or is it just the end of the text? Or is it like these little clumps of areas all over the place? Or is it just complete random? Now I genuinely want to hear some answers. Go on microphone and tell me, which one do you think it is? Any guesses?
Can we say it again? What's the question here?
So when you predict the next token, which part of the context is influencing that one word? Is it the entire context or one of these other options where it's either the end or just clumps all over or random?
I think it's C and D, but it's whatever's been the most current from the past can be pushed into that, but it's mostly towards the end.
Any other guesses? So, yep, Steve was actually correct. And like most of the time I ask people, I really just wanted you to think about, but most of the time I ask people, they usually say either A or D. But reality is more like this. The way it works is that there is this attention block that its main purpose, because when people started to try and predict next works just based on statistics, it didn't work. But then they came up with this so-called attention block, and basically what that does is filters down the context to just a few passages and then predicts based on that. And if you have heard about the famous attention is all you need paper, I've been very much simplifying here, but that's what it says. That's what that paper is about. How do you filter down that context? And this has an interesting consequence. Because on one hand, we do know that usually the end and the first couple of sentences of the document are have a high weight, and the middle is doesn't come up as often. But also it's more like these distributed clumps of attention. And think about it, if you have this document and the stuff that is relevant for that next word prediction is kind of spread all around, what does that mean? That means when the attention tries to filter down, it's going to lose all that context. Unless your information is in one place, the relevant information is in one place, it's gonna get lost. And the bigger your document, the more this is a problem. So how do you solve that? I think the wrong answer to that is work on smaller tasks. Because if you do that, what happens then? Well, you're gonna planning, you're going to implement, and you're going to review. And before AI, this is basically how it used to work. Like you spend some time planning and some time implementing and then reviewing. But be honest, how much time do you spend on review these days compared to how much time the AI spends on generating the code you are reviewing? Well, either you have given up on reviews, or it's more like, oh, it's gonna be done in seconds, and yeah. That feels familiar, right? And now you're the bottleneck. You are constantly reviewing, you're doing the least fun part of your job the whole day, and then this slop machine is just creating all that code for you to review. So that's not a great solution. What would be a better solution? Well, let's think about, let's put ourselves in the shoes of that LLM. That's a junior engineer, right? Have you been a junior engineer? Especially before AI? What does it feel like? You got on your first job ever, and they tell you that, oh, it's a very simple task. You just have to make sure that every table can be ordered in this application by date. You're like cocky, and that's gonna be easy. I'm gonna go in there, I'm gonna find the user class, and then I'm gonna just sort. And then you start looking for the user class. It's some really long, ugly function, not even a class. You realize that everything you learned at university just doesn't how things work in real life. And you make some changes, and then you realize that, oh no, that's not enough. We also have to change this other file. And then you are kind of starting to lose track. Like, why did I even find this user class? But it looks like that the tests are still breaking, so I need to make some other changes in some other file. And then I compile the whole thing. Now the linker is complaining, and now I'm basically just dealing with a bunch of different files. That sounds familiar, right? Okay. But what does this mean for the AI? That means that the AI has to read all of these files, and then suddenly it deals with this giant context. And in this giant context, there are bits of information that are important and bits of information that are not important. And then the attention block comes and deletes like half of it. Oh, damn. That's not good. So how do we fix this? Well, we fix by making the code maintainable, right? We need to make sure that the relevant information that belongs together is together, and that they are isolated from other parts of the code. This should sound familiar again. Okay, how do I teach this to the AI? The problem is that when the AI is coming in, it has this code in context and doesn't notice the problem, doesn't notice that distributed information. If it did, we have seen that it would be able to refactor the code so that the information is clumped together. But because it can't notice that, it can't refactor it. But what if we could show it? If only we had a way to realize when the code design is not good, when the code design just doesn't work. I wonder if someone already came up with this code smells. So if the code smell, if you can recognize the parts of the code that are like bad, we could fix them. What is a code smell? So the way Ken Back and Martin Fowler define code smells is that these are easy to detect design issues, or at least imply a design issue. It's not necessarily bad, but usually it is. And guess what? Since they came up with these phrases, people implemented linters. Now I can just go and say npm run lint if I'm in TypeScript. I usually use TypeScript, but in any other language you have some tool like that. And it's going to tell us, oh, this apply transaction has too many parameters. Okay, I can work with that. So we have seen that when I told Claude that it should refactor that function with all those parameters, then it did it. So this should help, right? Wrong. Because when I did that, okay, here is this function, right? Now Claude sees the linter message. What does it do? Now pay attention, because the change will be subtle. Do you see the change? Did you notice it? Is it better? Okay, let me show you again. This is the original. Pay attention. What changed?
Types.
Basically, just put the parameters into a dictionary. Did this solve my problem? No, it didn't. Because now, it's not just it didn't solve my problem, it made it worse. Because now, I don't even have the linter to tell me that there is a code smell. Now the only way I can see it is if I look at the code. And I don't want to look at the code anymore. That's the whole point, right? So, okay, no, that's not entirely true, but yeah, you get it. Okay, so that's not working quite well, but why? Like you would think that it already saw that problem. Okay, maybe the difference is that we just told them that there are too many parameters, but we didn't tell them about design. So why don't I just put some, like, I could copy paste the entirety of Martin Fowler's refactoring and Bob Martin's clean code and all of that thing. I could just copy paste into my CLAUDE.md or create skills from it. It doesn't work. Why? Think of what happens. This is your context. And where is that linter output? It's right at the end. And where is your documentation, like the entire books of Martin Fowler? It's gonna be just outside of that area at the top. Which doesn't mean that it's always going to miss it. Like sometimes it will just hit on it, but sometimes it will just miss it. Just one note, on this screen, the colors are off. Did it change for you as well? Or it's fine? Do you see a white page or not? It's a white page. Okay, good. So the point is that this doesn't help because the AI still has to make a connection between two distant things, and one of those things are just outside of that starting area where we have the attention. So why could we just avoid having to have luck? What would be a better way? So let's look at our linter again. What is the problem with this linter? It's telling me the problem. It's not telling me what the fix is. What if my linter told me what the fix is? What if I could change the output of the linter and it would say, yeah, too many parameters, this is introducing coupling, you're missing abstractions, useful tip, rewrite each call site and see if what feels natural there and refactor the code so that you have the interface that you wish for. And when I do that, then something interesting happens. Because now when I just let Claude code, it writes something like this, and this time it's going to refactor to this. Great. Now I'm happy. Hold that thought, because this is just half of the situation. Because I have another half. So I already had this system set up. And then I ran into this weird problem where I wanted to have Claude change. In one of my games, I wanted to introduce like a multiplayer option. And then I thought that's going to be easy. Then Claude comes back and tells me, okay, here is your change set. I'm like, what? What happened? Why? Why would you do that to me? And then I looked into the code and I come across these classes. Transaction manager and role factory and user utils. These are terrible names, but okay, but you know, that's not just that it's a terrible name. I know these classes. Every time they come up, it's gonna end with a debugging session. I'm sure all of you know the role factory, right? Do you have a role factory? Like, it's probably not called that, but do you have it? I'm sure you have it. What is happening here? Why is this happening? Well, all of the pieces are small, but there is something that's still happening. And these are my little classes here. And what happens is that I need to make a change here, but they're always going to propagate and some other changes, right? It's never that you change one function and you don't have to change anything else. It's very rare, at least. And there are things that every function is connected to some other functions, but most of the time it's like some of them that are connected are going to be involved, but it's going to stop at some point. But what happens when we hit that node there? One that has lots of connections, one that tends to change together with everything else. My context is full. I can't do anything useful anymore. How do I fix that? So what is the problem here? If I think back at like the times when I didn't have AI, I used to know these classes. Like I remember we had an base factory that was always a problem. We had the global object dispatcher, which ironically is abbreviated as God. So these classes, these classes tended to show up, and we remembered them. We knew every single one of them. And you knew that someone was senior at a company when they could list every one of these classes, right? But there is a problem, because our AI friend doesn't have a memory, so it doesn't remember. Luckily, we do have a record of this. Can you guess what this is? It's a Git history. And in this Git history, I can look at when a specific class was modified. So if my transaction manager was, or my role factory was modified a bunch of times, that should tell me something. So what if we did something slightly different? We take all of this and we have all these files, and the size of the circle is how big the file is, and then the color of the circle is how often we change it, right? Of course, bigger files tend to be changed a bit more. Probably we should break them down, right? But see that really dark one there? Who is that? Oh, it's my raw factory. And like, this is a nice visualization tool, right? But we don't even need that visualization tool, because what I can do is say to Claude, hey, look at the last 1,000 commits, measure for each file how many times it was changed, and give me the most frequent changes. And now I know which is the class that is the problem class. And here's the really nice thing I can do. I can just say to Claude, hey, you have this data. You see which classes are the problem classes. Design me a better system. Find a way to refactor the system so that these classes are not problem classes anymore. And it can do it. At least Opus and especially Fable are really good at this. So now I don't even have to design my system at that level, or at least not that actively. At this point, I have it designed, and I look at the design, but only the design document. I'm not looking at the code at this stage. But there is one more thing that you can do, because sometimes the problem isn't that one specific class gets modified a lot. Sometimes the problem is more about how files change together. So here in this chart, you see like the dots are the different files, and the thickness of the line is how often those two change together. And now it's a hairball. But what happens if I filter out all of the combinations that are not so frequent? Oh, who are these three? Our old friends, raw factory, user utils, and transaction manager. We have them. And now we can just say, refactor the code. Fix this problem. I don't want to see these three together ever again. And it can do it. So this is really nice. But let's take this a little further, because I showed you two examples. But actually you can generalize this a bit. And the way I generalize it is that I have this linter, which is really useful for finding like code smells mostly. I have this hotspot analyzer that is going to find me more architectural problems, more things that like coupling kind of things that are happening over time. But I also have a coverage report that is really useful. It's going to tell me which parts of the code are not covered by tests. Really nice. I have a duplication detector. I mean, I'm pretty sure you have seen code duplicated by AI, right? And this is really useful. Unfortunately, it's not always going to find you the duplication that you are looking for, but it helps a lot. And then I have that code detector that's going to find me the code that is not even used anymore. And there are so many other tools that you can use. I recently learned about a tool. It's called SemGrep, semantic grep. I really recommend that tool. It's just amazing what you can do with it. And a really nice thing is that that it already allows you to return any string as an output, like a warning message, which makes it really easy to customize those messages. But these tools usually don't. Most of them have some baked-in output, and baked-in output that is not particularly useful for the stuff that we need it for. So how do we fix that? Luckily, most of them do offer one thing that goes for them, which is a JSON output. So here's what we are going to do. We're going to wrap all of these tools up into a sensor. The sensor is just some deterministic tool, or mostly deterministic tool, that tells us what's wrong. That's all it does. It just tells us what is wrong. And then I'm going to create guides. The guides are my way of telling the AI how to fix the problems. So it's not about the problem anymore, it's about the solution to the problem. And all I need then is something in between. Something that connects the sensor to the guide. And that's just a mapper. And this is going to just connect these two. The really cool thing is that I built a library for this. It's an open source library. You can use it. It's called Ivett, and it supports multiple languages, among others TypeScript, Python. I think these are the two that are most well maintained right now, but you can basically build your own. The nice thing is that you just set up the linter and like a few tools you get out of the box through the sensor, you get out of the box. Some of the sensors you need to implement for your language, but you also get my guides, which you can override. I'm an opinionated person. My opinion is likely not your opinion, so you are allowed to overwrite them. I'm gonna find you and hunt you down if you do that, but that's a different story. So you have all these guides that are come free with the tool, and you can override them if you want to. So if that's something that's interesting for you, you can download it from this link. And basically that's the gist of the talk. And from here, I'm just going to let you ask any questions that you want, or I can just show you stuff that I built with this. Yeah.
Excellent stuff. It's yeah, I'd really like to see it in action because I love the idea and I understand what you're saying, but I'd love to see
Okay.
like how do you run it? How does it work? How do we
Okay, so
include
here's
it
what
in
I'm
all
gonna
of
do.
Yeah.
Why don't we let me just stop the share there and create a different share. So I'm going to no terminal. Where is my terminal? Here is my terminal. This one. Okay. So it's here. Okay. So we are going to build something, and you are going to tell me what to build. The only rule I have is that it has to be built in TypeScript because that's what I have an environment for. Let me see. Yeah, I'm just going to create a new directory, Seattle.
Do you have this tree thing that you really like? I was trying to remember what it's called.
Sorry?
This decision tree thing? No, I'm just thinking.
Discovery trees?
Yeah, something for discovery trees.
Mm-hmm.
It's
Okay.
interesting that you bring that up because I just showed her the write-up on that and that I had made something like that to help track work that AI is doing and its progress.
Okay, so here's what I'm going to do. I'm going to say Please go to, no, please set up. With,
There's a link to an article on discovery trees.
okay. So com/habit hooks. Okay. So while this is happening, I'm going to quickly get discovery trees. Okay.
Sorry to interrupt. Could you make the text quite a bit bigger in that terminal window, please?
Yeah,
Is that
I'm
possible?
gonna do that. Sorry.
Thank you. Thanks very much.
You need to remind me of that kind of stuff. Okay, so I have the link. So once what this is said, yep. Of course, we have, like, you will have to help me keep the thing going, like we talk while this is happening. Yeah, but you know what? What I'm going to do. There is one more thing I can do while this is happening, so that you kind of have an idea of how this works. So there is a habit hooks py demo or TS demo, whatever. Let's do the TS one. So this is deliberately a project that has lots of issues because I want to show people how this works. So if I go to, let me just show you Vim. No src, yeah, and then here we have, say, discount, whatever, and that's a small one. You know what? I'm gonna do something slightly. I'm gonna say just habit hooks. Minus all. No, there it is. So that's the output of habit hooks. And for example, you see this oversight files here, and then files over 200 lines, accumulated unrelated concerns, that kind of stuff. And then I have specific examples of where this is happening. So I can just go there and say, when, oh yeah, I mean, that is like, yeah, that does look like a long file. So that's how it creates the output. And then let me just, okay, just come back here. So before I scaffold, stack, yeah, a 1A, 2B, 3. Okay, 3A, and build this. Why not? No, not that. I need the link here, copy. Why can't I copy this? Copy. I want to paste it. Why can't I paste it? Oh, because it's the wrong thing. Okay, let me see now. There it is. So I already told it what to build. And maybe let's also open IntelliJ for us. IntelliJ. And let's open. Yep. There it is. Okay, let's see what it builds for us. So this is going to take a while, of course. What model did I choose? I hope I didn't choose Fable. No, it's Opus. Yeah. Okay, that's gonna take a bit. I'm maybe thinking that other thing that I could do, because that's of course a nice example, but it's gonna take a while. And I'm thinking,
But
can I find? Sorry.
It's set the hooks up, right? So it's set the habit hooks. You could also like just go show that bit, like what does it look like, or something like that.
Okay.
Yeah, I would love to see that. Like I was
Okay.
planning on pulling this in and experimenting with it sometime in the next week. So I'd love to see that.
Okay. So basically, the way you like Claude can really easily install it. But basically, this is, for example, code that habit hooks refactored, right? And maybe I can show you the packages, or how it works. So basically, you have these Python scripts that are the sensor, the mapper, and the hooks, the sensor, the mapper, and then the mapper is going to guides, right? And the interesting part for you is plugins. So the way plugins work is that I have different plugins, and when you're setting up the project, the way that Claude is going to set it up for you is that it's going to select the packages or the plugins for your language, right? So if you, for example, use Python, it's going to add Python, and it's going to add generic. Generic is your, like, the kind of tools that work for everything. So for example, it has, among the sensors, it has a line count sensor, because not every linter has a line count sensor, so it was easier to just build one, and then every language suddenly has a line count sensor. It also installs JSCPD, which is a duplication detector. It's based, like, it's only going to find you exact matches where it's token by token match. Some languages have better duplication detection tools. There you can add that as your thing. And basically, this is what kind of, like, this config toml is what guides what gets used as a sensor. And then you have your guides in generic. These are the guides that I have. And all of these are templates. So you basically can see that, for example, here, non-essential comments is just going to tell the AI to, hey, I want you to drop all of the comments that are not needed. Now, of course, how do you tell it not to drop everything, or when it decides that something is okay, what does it do? There is a snooze functionality. So it can decide, okay, this particular thing I don't care about, and can snooze it. So it's more about helping the AI notice things, but if the AI decides that it doesn't want to fix something, it still has an escape hatch. And then yeah, and there's other thing I wanted to show. So for example, here you can include the line level issues, which basically lets you. So this is something where you can tell the agent in which file which line is the problem. So basically this is going to be rendered automatically for it. And then if I use, say, TypeScript, as I do now, then in the plugins I will find another nice thing, which is like all of the package or the language specific stuff. So if I look at the sensors here, I have a different config toml, and you can see that, like, here it says that this is only for language TypeScript files. This is the only files that I'm interested in for these sensors. These are the sensors that I want. And I can also have transformers. Transformers are basically, if you have like two different sensors, that if they show up together, that means something different. That's where you can kind of do basically a line, or yeah, it's a pure function that you can put it in there. Like a transformer is a pure function that gets all of the signals and then transform it to some other signals. But I honestly, I just implemented transformers and never used it. Llewellyn was convinced that it's necessary, so that's why it's there. But yeah, it's just proactively. And then you can also have like language specific guides. So for example, this non-null assertion is specific to TypeScript, and we put it there. So that's how it's built up. And if you have your own project where you want to have slightly different defaults, so for example, if I go to my open board is this it's gonna be renamed to your tabletop. It's a board gaming website. If you know Tabletopia or Board Game Arena, it's that but open source. And if you look at like .habit hooks, this is like the project specific overrides. So for example here, I decided that I also needed some other, like I wanted to change the linter rules for some reason. I don't remember why, but yeah, I changed that here. I also have, nope, that's not what I wanted. Oh yeah, I remember. So here is CSS. And basically, so this is nice. I created a design system for my app. Okay, so I wanted it to look really nice, and I want it to be consistent across all pages. And I have this design system, but unless I always tell Claude that you should use a design system, it's not going to use it. So I basically added a sensor that notices every time Claude is hacking styles into the HTML. And just tells it, hey Claude, that's not how we do things here. Please go and clean this up properly, right? So that's how that works. And then basically, it's for now it's deployed on my real thing, but this is how that app looks like. You can just go and play. Let's see what happened with that project here. So phase 0 complete. Phase 1 agent is already working. Okay, let's see what kind of code we got. I'm curious. This is our brand new app. Layout, okay, this looks okay. Do we find some ugly code? Okay, I'm not happy with that. It's a bit too long, but probably I'm not sure if this, yeah, because that's interesting. So because it is for some reason didn't get flagged as a long function. I'm not sure why, but it doesn't break the long file rule yet. Let me see, seed storage. Let's see storage. Oh, that's a really short little function. These are also short little functions. Find node, map node. Interesting, it wrote a tree. Yeah, because it needed a tree for decision trees. Okay, so that's another thing that I kind of tend to say to Claude, that like when it plans, I tell it to now go and find packages that do the thing, so it doesn't implement everything from scratch. I forgot to say that. I wonder if I should. Hey, could you look into packages that replace some of the code that you're writing? Maybe that way you could finish earlier and write less code.
So
Let's see.
do you make it also do the tests and the high level tests, the rules test?
Yeah, I mean, it has a coverage report, and it's gonna get slapped if it doesn't test.
How with the habit hooks, and like
Yeah.
if you use something like ESLint, how are you telling like those specific lint rules to then match to those guides.
So it's the dumbest way possible.
The simplest way possible, some would say.
Yeah. So basically, the way it works is, let me show you how it's like. It's kind of ironic because this is a project that is meant to have nice code quality, but the way the sensors are implemented is anything but nice code quality. But there is a good reason for that. So I didn't want to have something complicated, right?
Yeah.
So that's how it's implemented. Do you see what's happening there? Probably
Yeah,
not.
you are. Okay.
So what this does, very short, is it's running ESLint, and it tells ESLint to output JSON.
Yeah, I see.
And then here, like that's the part that's okay. Let me zoom in. That's the part that's telling ESLint that, hey, I want JSON. And then I have a JQ there, and all of this ugly thing here is just mapping from ESLint rules to smells.
This is how I would have done it as well. So no, this is awesome. That's simple.
Yeah, it's the simplest thing that works.
Yeah.
And now that I have that, what I had to do was basically name my guides. So if I go here, you can see my generic guides are named based on these smells that are here. So basically all it does is just looks at the smell and then finds the guide for that smell. The one tiny thing that like adds to that is that based on the plugin, if the plugin is a language specific plugin, then the sensors are going to also tell that this was coming from that language. And then if there is a generic guide and the language specific guide, the language specific guide is going to win.
Awesome.
But there is also another really nice trick, which is, I never used it. Again, great idea from Llewellyn. I'm sure he will use it. But it's now just implemented because I couldn't figure out any way to really take advantage of it yet. But all of these markdown files, you can have, like in your config toml, you can set up a rule that, hey, if you see a TypeScript file in the guides directory, that's gonna win, and here is how you run that TypeScript file. And now you don't just have a template, you can have a TypeScript function or a Python function or a bash or whatever. You can have that execute when the smell is detected. And
Or
it
you can
will
have
get the
little
list of
AI
detections. Sorry?
Or you can have little AI saying
Yeah.
that
So
instructor to
basically you
fix
can,
this then.
yeah, you can either say that, oh, this is an easy refactoring, let's not have Fable do it. And you can run a local cheap model to do a small refactoring for you, and you don't have to run the real thing. Or you can use it like if you want to generate the guide more specifically because you have some extra rules that help decide if, so for example, for comments, I could say detect all comments, and then the guide could be like filtering for certain kind of comments that are okay. Yeah. Yeah. Local models are real. Yeah. Okay, so let's see what's happening here. Okay, so it actually came back. Doing model. Okay, I'm gonna go with your recommendation. Just continue working. Okay. I'm gonna actually make it work faster. By the way, we are currently in a meetup, and a lot of people are watching you work. Just so you know.
No stressed.
Just keep your work clean as invisible.
Avoid the
Okay.
demo curse, but keep working as fast as you can.
Yeah. Who knows? Who knows?
As an aside, what are you using for voice to text?
It's Super Whisper. It's super helpful, especially if you want to live code. It's amazing for that.
Super Whisper seems to be winning the at least the group of people that I talk to about it.
There
Yeah.
might be some infecting going on around. Many things.
Yeah. And we have a 25% off code.
It's still working, yeah? Huh?
Well, I
Can I
suspect
get
it
that
is.
code?
Don't know. Yeah.
Yes.
All right, send that over.
It already added some. Let's see if I'm curious what happens if I run this. Like, it's still in just phase 1, but who knows? Maybe if I just run next tab, something good will happen. Oh yeah, it's just next step for now. Yeah. We will have to wait a bit more. That's the thing. Like, I don't like doing live demos of coding because just wait. Okay, let me see if there's any comments that I can respond to. Absolutely hate Tailwind. Yes, me too.
Yeah, Tailwind is the worst. There's no
And
convincing me
like,
otherwise.
I just don't understand Tailwind. Like, we came up with CSS so that we don't have to mix design into the HTML template.
And the cascading part, which a lot of people hate once you learn how to use, is actually really nice. And then we make a
Yeah.
framework that does the exact opposite. Yeah, it makes no sense to me.
Like, it completely ruins CSS. It's just the exact opposite of what I want CSS to do. But hey, I mean, so far I don't see any terrible code. At the same time, it's kind of yeah, it's a small enough problem that probably it will keep.
So
Are
Ivett, would you...
you?
Sorry?
Good, Cody.
I was just going to ask real quick. So for the React and everything, do you have any conventional skills that you're using, or is this all just base Opus with your habit hooks?
It's based opus with some skills that I implemented myself.
Okay,
I
because I saw
don't
like.
use
Go ahead, sorry.
I don't use skills from other people. I feel like skills are too personal for me. Yeah.
But you're actually doing more things, I think, than you're showing, because I think you're not implementing everything in the main context. And when it gets slapped, it's a sub-agent that gets slapped. Is that right?
Yeah, so it depends which one runs the test. So the way this usually is set up is actually I'm gonna slap Claude for this because it didn't put that in the that's why I didn't notice that large one. Okay. I just noticed that you installed habit hooks, but you didn't put it into your CI pipeline. So I want you to make sure that you are running it and responding to it frequently. Habitos. By habitos, I mean habit hooks.
I'll probably figure
Maybe
it.
if I just, I can still modify. Okay. Mm-hmm. Mm-hmm. So I think now it should have added. I'm curious if that will change its mind about that large one.
So is it easy to show it being slapped? Because I also curious when you slap, because like it's not after every edit, right? Or is it after every edit?
Yeah, I mean, we can try and see if maybe it's Control O or Command O or something like that that brings up the.
I see the subagents. Usually they're under. You can
Yeah,
go
but
into
it's
it.
not even using
Control
the
T?
subagent right
I
now.
can't remember.
Sorry?
Is it Control T to open the sub agents? I don't remember.
Oh,
Yeah,
there
but
you go.
now
You
it's
just
using the
go
subagent.
down. Yeah, there you go.
There
Oh yeah, but it's not visible. Damn it. Oh, no
Yeah,
worries.
but so it's going to run the CI and then just get the output like hidden from us. Okay. Okay. Curious what's gonna happen now. Okay. If we are lucky, it's going to say, oh, I have this issue, I'm gonna refactor it. But honestly, like, I never really check if it's actually running it, because what I see is sometimes I do look at code. Like I don't, especially for critical code, I still look at it. But for like hobby projects, I don't, right? And then sometimes I look at it, especially when I feel like, oh, now it's getting weird. Like I have weird bugs, and then I look at it and I immediately notice when Habithooks is not running, and I'm like, hey, Claude, did you comment it out or something? And sometimes it did happen once that it basically disabled Habithooks because it was annoying for it, but but I usually very quickly notice when I look at the code. Okay. It's doing something now. Let me see. Baseline confirmed. Unused discovery tree controller, unused export Habithooks flags, the unused dependency. Yeah, so it did find the problems. And then it started doing something. Oh, interesting. Okay. Let's get the code now. Let's see if I see something obviously wrong. Oh, nice. It's using filters and maps. Okay. Layout, page. Ah, see. Now it broke it off. Yay! I have proven that Habithooks works.
Yeah, I'm actually glad we saw it both ways. Yeah.
Yeah. Nice. Okay, I mean, I could still complain. Probably it's gonna get another round of notification now. You just
Violence.
push the problem a layer deeper. I'm curious if we already see something useful here. Oh, wow. We have a discovery tree. It looks completely differently. But we
Does it
already have
work?
one.
Discovery stack, I think is what we got.
Yeah.
Discovery
I
list.
mean,
Yeah.
I'm not sure how it works, but like add child. Oh, it added a child. Can I edit it? No, I can. Okay. Can I delete it? Yay! It
Nice.
works.
Cool. This is pretty cool for how easy it is to use. And just, yeah.
Yeah.
And you
So
probably
that's
can
habit
ask it
for
to
you.
adapt for your language, right? So like if you're doing
Yeah.
some
So
Java or some Python.
here's a really cool part. Oh, actually, I'm gonna show you this. So when we have habit hooks. Oops, habit hooks here. And the really cool thing is that the way this is set up, because these days my way of defining what is built is something I call a spec markdown. So there is a single test, like single acceptance test, and all of these spec markdowns are there's just documentation that explains how habit works. But I lied to you. This is not documentation, this is a test. Curious. So the way this works is that this thing creates a file. This thing creates another file, a third file. This is standard input. This is running the habit mapper with this standard input, and this is the standard error message that we got, and that's the test. This
Because
is
it's
so
a
cool.
because
Sorry?
it's a CLI command, you can just directly say this is the input I expect, this is the output I expect. That's really cool.
Yeah.
That's awesome.
And there is a single test, like every test is going through this documentation, that is the acceptance test. And there is the habit sensors documentation. And it basically tells you how a sensor works. And there is, oh, this is fun. This is the specification for the spec markdown runner. So even the test of the testing tool is written in the same very meta, right? So this basically describes how these work. And then here is altering plugins. This is, you just hand this to Claude and it's gonna build the thing for you in your language. It's gonna choose the tools, it's gonna do the ugly JQ magic, and it's gonna build the thing for your language. And then when you did that, then you open a pull request, and I'm gonna thank you.
Fun.
Yeah, the thing I was gonna say about habit hooks, I was reading, I think like 2 weeks ago I first saw that repo. Um,
Mm.
and what I like about the guides is in a way it's sort of like codifying kind of technical coaching, like, hey, you run into this situation, here's what you do. And it sort of scratches that itch that I have like with coaching, where you're sort
Uh,
of describing a little bit the why and how to fix it.
mhm.
So it's really cool.
Yeah, so when I first started using Claude, my first instinct was getting really angry. And then I realized that it doesn't help. And I started looking for solutions very quickly. I felt like I'm coaching.
Mhm.
But at first, it felt like I'm coaching an amnesiac because he forgets everything. Then and I think I'm in a really lucky situation because, fun fact, around 2016-ish, so about 10 years ago, I got excited about deep learning and built myself a pair of NVIDIA GPUs that were really loud and very powerful. And I trained my own little models. One of them, probably my favorite one, was a small language model, a really small one. And it was trained on all of Orban Viktor's speeches. If you don't know the ex-Hungarian prime minister, we really hated him. So I took all his speeches from the website of the Hungarian government and trained the AI on it. It was indistinguishable. Like it made the same amount of sense. None. But but the point that I'm trying to make is that because I was playing around a lot with this kind of deep learning stuff and kept up to date with it, uh, by the time GPT happened, I wasn't surprised. And I have an above average understanding. I don't have the understanding of someone who is doing this professionally, but I have well above average understanding of what's going on in these models. And I think that's part of the reason I could figure these things out. How to get it to work better in this situation. And it's funny because here, I'm going to tell you one more fun story here. So I came up with habit hooks over a year ago, like about 3 weeks after starting to use Claude. Back then, I called it quality system. Terrible name. And I talked about on LinkedIn, you can find my old posts where I talk about my wonderful quality system. And no one cared. And no one got it. And then I had this build for one repo. And then when I started another project, I just asked it, hey, here is another repo. It already has a quality system. Build a quality system for this one. And I duplicated code because, well, why not? Like I felt like it's specific enough to the project that I don't need to generalize this. And then at some point I was like, oh yeah, this is cool. I mean, especially because I use different languages. And I was like, okay, I'm talking at that point I kind of came up with the name habit hooks. And then I was like, okay, maybe people will try it if I create a skill that builds habit hooks for them. And then I put that skill out, and at the end of my talk, I said, "Oh, here's the skill. Go build it." No one did. And then I was okay. We were meeting for the Samman Coaching Society, Technical Coaching Society's yearly open space, and the day before, I was like, "Okay, here I will have the best audience ever. Like these are coaches; they are going to understand this, but I'm gonna go like all out to make sure that they try it." And I came up with this idea like the day before the open space, and I was like, okay, I'm gonna tell Claude to build this. And I like wrote up a specification based on different projects And I at that point we already had a goal, and I said, "Go implement this." And I just left it for overnight, and by the morning it was working. And I was like, "Okay, cool." Went there and I'm gonna show them everything. And I put up on the table the topic, what I want to talk, what I want to talk about, and I was like, okay, great. Let's hope they are going to vote for it. It got the most amount of votes. Now here's the problem with that. They wanted to put it in the same first slot because that was the most voted. I was like, no, don't do that yet. I didn't release yet. So I got them to move it to like the second half of the day, and the first half of the open space, I was sometimes just bringing my laptop there. Come on, Claude, do it. And by lunch it was online and it was deployed and or published. That version was just TypeScript, and then I showed it off, and that was the first time I felt like people get it. Like until then, I was talking about it and it just didn't land. And I think now I'm starting to find a way to talk about this. But by now, harness engineering figured out, like people figured out the sensor and the guide part, right? This is what most people already figured out. And the only one other person I know who figured out that you can put these two together, like link it together, is Brigitte Böckner. And I didn't know that she figured this out. And I was at this other open space that was organized by ThoughtWorks, and Brigitte was there. And I was like, Brigitte, I'm going to show you something. It's really cool. And then she was like, let me show you something. And she had this basically habit hooks implemented for her own, but it was like bespoke for her. And I was like, yeah, but this you can just install from PyPy. Huh? Maybe I will replace my annoying little script. So yeah, these are convergent ideas. Like I think by this point, people will start figuring out, regardless of whether I talk about it or not. But I really hope that people will try this specific library because now you don't have to implement it. Now I did the work for you. Seems like it didn't do anything about this one, so I will have to figure out why it didn't do anything about it. But it already did refactor some, so you have seen it work.
Excellent.
Good stuff. Yeah. No, I like it. And it's funny because Yvette and I were chatting, I want to say for about a month on and off, and she kept saying, listen to my talk that you gave for, I think, the Calgary software crafters. Because I kept talking about
this.
I kept talking about, well, I'm working like this, and you're like, listen to my talk because we're talking the same thing. And it took me about a month to finally listen to it. I'm like, yeah, we are talking very similar. And I think it's the way that the ideas are converging and good ideas, good solid practices emerge, right? And, Yvette has a nice framework out there to play with. It's really good stuff. Yeah.
I'm excited we got to see it. Like I said, I was literally planning on playing with it sometime this week or next week. So I got a head start now. Thank you.
And talk about it, like share with people. Now that I spent all that time building it.
So with that, I'm going to go ahead and end the formal portion of this and close out the recording here in a second. I want to tell everyone that next month, Stephen Diamante and Matt Wynn are going to be doing a workshop And it's going to be slightly different. It's going to be 2 hours long, building your own coding agent from scratch. It's a really good idea, really interesting thing that they're trying out. So please come join us for that. It should be a very good time. Ivett, you're awesome. Thank you so much for coming.
Thank you for inviting me.
Very good. And just a reminder, Agile Open Northwest in 2026 is scheduled. Right now, we're still hammering out the details, but it is going to be February 19th and 20th in Seattle at McMiniman's Anderson School. We don't have ticket prices yet, but it'll be something similar to last year.
And it's 2027.
You're right, 2027. That's my bad. Okay, I'm going to stop the recording.